So the last portion of today's lecture is coding practice for ML. But before starting this, I'd like to just highlight what we learned because it was quite rushing to cover all. But the most important lesson I'd like to deliver from the lecture 2 is the classification of ML, machine learning, and that is supervised learning, unsupervised learning. That's the two main, and adding the reinforcement learning here. Supervised learning, the very unique thing about this is it needs an output, the label, so that it learns a mapping from input to output, and it can be used for classification and regression. And the supervised learning algorithm, we learn KNN and decision tree. And don't feel like, I mean, do not focus on individual algorithm in too much detail. That's almost impossible to learn the individual algorithm, but it is more important to see the big picture of machine learning from this lecture. And for your future research, you can learn your own specific algorithm and apply that to your own research area. And unsupervised learning here is there's no output, but learn the patterns of the input data. And example here is a k-means clustering. Both supervised and unsupervised learning is actively used in the built environment because we have a lot of data availability that you learn from the data access part. I think it's a Wednesday. So many open data sets that you can use. So utilizing those open data source and applying the supervised unsupervised learning technique will create a good research outputs. And the reinforcement learning is what I newly introduced here, and it's kind of getting the reward instead of actual output, and the reward is from the environment. So my own example here was the light learn, and that is interacting the lighting system with the occupants, and the lighting system will learn the behavior pattern and the preferences about the user, and then try to play the game with the user every day. And by playing the game every day, it learns the rule to meet the goal, which is occupant comfort while saving unnecessary energy consumption. So that's one of the key algorithm in the built environment, especially for the building control and control research. Okay, any question on the lecture contents too, before we move on to the coding practice?
No?
No? Okay, sounds good. So let's go to the coding practice. Okay. Skip the very first part. So now we'll use the building energy data for learning classification algorithms using the KNN and decision tree. Let's work with data, more fun parts. So the main objective about this ML algorithm is we would like to, or can we classify the building location by their energy consumption pattern? So building location here is, hold on. Sorry, everyone. So there was some sound outside, so I was just checking. Sorry. Is everything okay? So let's move on. Uh, share the screen again. Not now. Okay. So let me go back. So basically what we're going to do is utilizing various energy consumption pattern. So what was the TV energy consumption for TV? What is energy consumption for HVAC, heating, ventilation, and so on? There are multiple submeters for the energy consumption pattern. And based on those submeter of energy consumption pattern, can we classify the building location? That is the main objective. The building location here means, is this building located in rural or urban cluster? Okay. So in this case, can anyone try what is classification target? Is this I already say it's classification. So what is the classification target?
To find the building location.
Yes, building location. So either urban cluster, or rural. And the feature here is energy submeter consumption pattern. So in this case, is this supervised learning problem or unsupervised learning problem or reinforcement learning problem? What do you think?
Maybe it's supervised. Reinforced learning.
No. It's, can you guess
It's
again?
a supervised learning.
Yeah, supervised learning. Why it's a supervised learning?
Because we know that if the consumption level is low, that it could be in a rural setting or something like that.
Yeah. So the main key points about the supervised learning is we need to have the labels, outputs, and we have the building location. So that is the output and label that we are going to learn. So this is a supervised learning, like you said. Okay. So here's a data description. I already divide into train set and test set. So test set is around 1,686 building. This is a completely hidden, and this will be used for the final test, okay? And which is not validation set. On the other hand, train set has 4,000 buildings and features, like I said, various energy consumption submeters. There are 26 different categories, and target is 3 different classification: urban, rural, and urban cluster. Okay, so it's the same 26 and 3, but divided into train and the test set. The 26 features are for example, like electric usage for space heating, main and secondary in kilowatt hours, air conditioning, water heating, air refrigerators, first refrigerators, second refrigerators, freezers, cooking, microwave, clothes, washers, dryers, dishwashers, indoor outdoor lighting, televisions, air handlers, evaporative coolers, ceiling fans, humidifier, swimming pool pumps, hot tub pumps, and so on. So these are all 26 features that we're going to use an X input. These are inputs. The classification target is 1 to 3. 1 is urban, 2 is urban cluster, and 3 is a rural location. So basically, input of these various electricity usage information or data to classify the building location. That is our role. And okay, before going into the real coding, any question about our objective? Any question on chat, Tanner?
No, I don't think I see any.
Okay, so I think it's quite straightforward. And these are 8 major steps in this coding practice. So first step is read libraries and download files. And then second step is read data based on those download files. And then split the data by features and target and train original model, which is a decision tree and candidate, and cross-validate of your original training, tune your KNN model, test your final model with the unseen test data, and report your final results. Okay, so now you should open your Jupyter Notebook with MyGeoHub. So firstly, you have to go MyGeoHub, and then click on your coding practice, and click this ML Python empty.ipynb. Okay. Okay. Let me go to dashboard. Okay. Courses, terminate. For yourself, go to courses and then go to Friday, coding practice for ML and ML Python empty Jupyter Notebook file. If you open that file, the first two lines are filled out with some words or codes, and 2, 3, 4, 5, 6, 7, 8 is empty. Okay. Any issues until this step? Did you get any like issue from chat, Tanner?
You see. But no issues. Yeah, it looks like no issues. Oxen, I assume that's no issues, you mean, right? You were able to open it?
Yes, I was able to open it.
Okay.
Okay,
good.
all right. So seems everyone okay. So the very first one is, I don't know how you learn this Jupyter Notebook, but I usually put Shift Enter, Shift Enter, Shift Enter. The very first like block is import pandas as PD, import numpy as MP, import matplotlib pyplot as a PLT, seaborn as SNS, import collections, import requests. So very first two is pandas and numpy are data science libraries that you can use. The second and third and fourth is visualization plot. I think previous lectures covered those four libraries. And collection is something I newly introduced here, that this library helps like aggregate and collect the values. The request is something you can request through the URL to download some data. So you have to run this by Shift Enter, and I think we already provide this, so it won't take that long. And then the second line is 1A, which is a downloading data needed. So repository URL is we already upload the URL link to the here, and then it's a data all.csv, data test CSV, and data train CSV. Those files are downloaded. And this for loop is basically showing how we like download. So if it's successfully download, then it returns these print this download successfully. Otherwise, you have failed to download.
If you guys remember in the intro to Python or the data access slides, when we did the building genome example, this is an application of that again. Very, very similar, just for multiple files. So I just wanted to chime in on that. So
Thank you. Any problem so far? Any error that you encountered so far?
No
Everything good?
problem. Yes.
Okay. So now let's go to the slide. So next one is read data and read data. So data equal PD read CSV data train.csv data.head parentheses open and close. That's basically checking your reading. And len data is how many rows that you have. Okay. So please write this code and run by yourself to see if you're working well on these.
Which one do you want us to try?
Oh, this one, data train.csv, this one, on the slide that I have.
Okay, data is equals to PD dot read CSV.
Yeah. So all these codes, 3 lines. Yeah, everything. So basically the first line, data equal PD dot read CSV, is reading that data train CSV file as pandas data frame. And the pandas data frame name is data. Okay. Once you read that, then you can dot head to see only 5 first rows. Okay. Length of the data file. Everyone good?
I'll let you know if an issue comes up, but for now I don't think so.
Yeah. So let me write down here as well. So data train. So I read this CSV file as a data, and data head is basically showing very first 5 columns, no, rows. And the length of data is, what is the length? Basically, how many rows does data have? So back to my original slide here, 4,000 building for training set. You can check it out. The length was 4,000, and that's really the training set. Okay. All right.
Can you put back the slide? Okay, yes.
Yeah.
Dot head.
Getting a couple of yeses, the code ran and is finished in chat.
Okay. Sounds good. Sounds good. Whenever, Joseph, you're ready, we can go to the next step.
Okay.
You're good to go?
Yes.
Okay. So the next step is we need to split this data by feature and target. So X is typically, we are referred to input. So iLock is splitting this data by until 26th column, every row. So basically X equal data.iLock, bracket open and bracket close. This means we are selecting only 26 column from the very first column and every row. And you can check it out by X head. Once you're done, you can do Y equal data location. That's the name header of your label or you want to target. And if you put the head on it, then you can see the labels on it. Okay. And collections that I used previously, collections.counter y, that returns how many 3s, how many 1s, and how many 2s. So 1 was urban, 2 was urban cluster, and 3 is rural. So majority of them are urban, which is around 2,700, and 400 for urban cluster, and 800 for the rural area building. Okay. Let me do it here. So x equal data dot iloc and till 26 column, and then x head showing this, and then y equal data location, which is the very last column, and then y head is this, and collections counter y returns how many 3s, how many 1s, how many 2s. Any questions so far? Any problem issues?
Can you repeat what the counter does again, please?
Yeah, so counter is basically how many 1, how many 2, how many 3s. So 1 is urban. So there are 2,759 buildings in urban location, and urban cluster is a 400 building, and rural area is 805 buildings. So it's a one line of code that counts how many 3s, how many 1s, how many 2s in your location Y, which is a Wi-Fi.
And
Is
is that a built-in function, or is that from a library?
Yes. So I added here import collections. It's kind of built-in library function. As long as you read or call this collection import, then you can use it quite easily.
Okay, thank you.
Any question or any issues so far?
Oxa, is that for when you're calling the like head function for the data frame, or one person's posting in chat that they're getting 4,000 rows instead of just the 4 to 5 the data frame normally shows?
Oh, so maybe without head, then 4,000 rows. So is it question or error? Go chat here.
Because earlier for the data length should be 4,000 rows. That's what I got
Yeah.
as well. But that's
Right.
before splitting. Okay, got it.
So yeah, okay, solved. Everything good?
Think so.
Yeah. Okay. You good, Aksha?
Yes, she said it was solved.
Okay. All right. So the next step is we need to train KNN and decision tree model. So for this, you have to read this sklearn, which is a scikit-learn library, and import tree model and neighbors model. So from sklearn, import tree, comma, neighbors. The first line is reading tree model and neighbors model from the scikit-learn library, which is like collection of machine learning models in scikit-learn. then you want to compare the tree model and neighbors model. So model 1 is tree dot decision tree classifier, parentheses open and close. Basically, it's reading this tree decision tree classifier model. And model 2 is neighbors dot kneighbors classifier, and just default setting is a n neighbors equal 1. Remember, we have to define the n neighbor numbers, and the default here is a 1. So model 1 and 2 is basically reading those decision tree classifier, k-neighbor classifier into model 1 and 2. And then the next step is model 1.fit x, y, which is a feature and classifier. Model 2 fit x, y. So learning those two models based on the input x, y, and output y of that 4,000. Any questions so far? Sklearn, import, tree, neighbors, and then you're reading model 1 equal tree dot decision tree classifier, model 2 equal neighbor dot k neighbor classifier, and neighbor equal 1. And I would like to train my model 1 using whatever I already make for x, y. Model 2 fit x, comma, y. Any errors, any problem, any concerns so far until step 4?
I don't see anything in chat as of yet.
Okay. And as you can see, you can also do this kind of stuff. Model, like test tree dot, and then if you click the tab, you can see all the tree models that you can use. Because it's a decision tree classifier, but you can put decision tree regressor or extra tree classifier, which is another algorithm, and base decision tree. So these are all the functions under the tree, okay? And neighbors, click tab key. These are all available neighbor algorithms: k-neighbor classifier, k-neighbor regressor, and near centroid, different types of the calculation method. You can use these other algorithms to test it out. So like using tab key and hovering around what other algorithm you can use is fun, but this is classification algorithm, so you have to put the classifier for this. But if you are interested in regressor, then you can try the regressor later on. Okay. Any question? Can I go next step? Yes or no?
Don't see anything in chat. I will let you know.
Okay.
Yes.
Okay. So the 5th step is now you have to do what? The cross validation. Can anyone answer why we need a cross validate? Why we need a cross validation in machine learning process?
To achieve the accuracy.
And in other words, we have to balance between bias and variance error. In other words, we would like to avoid underfitting, overfitting, right? That's why we need to do cross-validation. Achieve accuracy, more realistic accuracy. Okay. All right. So the very first line here is, again, from the scikit-learn, there's a model selection, and then import the cross-validate. And model 1 cross-validate CV equal cross-validate model 1 X, Y, and there are various scoring methods, but this is a precision macro, which is one of the typical method of doing the scoring. And cross-validation, the fold number as a 5, and return train score false. Same thing, model 2, exact same thing, but change the model 2. And you can like decision tree score and k-NN score here. Let me move this one a little down. Then so from sklearn model selection, import cross validate model, model 1 cross validate equal cross validate model 1 X, Y. What was X, everyone?
Energy
Is it?
consumption.
Yeah, feature, energy consumption. What was the Y?
The location.
Location, the label.
No. Yeah.
Yep. Scoring equal precision macro. CV equal 10. Return train score false. Copy, paste, just 2, model 2, model 2. CV 5.
Can you explain the code here, like if you have time?
Yeah, sure.
Yeah.
So model 1 CV is basically I would like to store all the results by cross-validation of model 1. So cross-validate is whatever I import from the scikit-learn. So if you specify your model, which you learn the previous step here, which is by decision tree, and X was input data, Y is output data, and scoring is your own scoring method, but precision macro is one of the typical scoring method in cross-validation in here. The CV is how many splits, how many terms you want to split. I make a 5-fold cross-validation, and this return train score is just false to make this slot is cleaner. And model 2 is basically exact same thing, but changed to model 2, which is a k-nearest neighborhood. Previous code, we learned model 2 as a k-NN.
What I did not answer, like return a train score is equal to false means what do you mean by like true or false there? Like, is it like,
Yeah, you can make it true, and that will return all the scores about training. But the reason I make a false is just to like save the space.
Okay.
Yeah. And print decision tree NP mean model 1 CV test score copy and paste. Second one was KNN model 2 CV. Model 1 CV test score. Why do I have 5 scores in model 1 cross-validation? Can anyone guess?
Because you have set the CV as 5, right?
Yeah, CV as 5. So I did the 5-fold cross-validation. So if you go back to the contents one, where I explain the cross-validation, what I specify here is 5-fold, split 1, split 2, split 3, split 4, split 5. 5 different results and take an average to get the cross-validated results. Same thing. I have 5 different results and take the mean of it, and which is a 39 of decision tree, 39 for KNN. Good answer. Any question?
There was one in chat, but I think I answered it. Step 2 was, I think, missing from the PDF. So I attached just a short screenshot if you needed those commands. The pandas read function for reading the CSV and the data head function. I attached a screenshot of that inside of the
Oh, you attached
chat.
it?
Yeah.
Okay. Thanks, Tanner. So let's do, if I'm changing this, it's 10, 10. Now we have more scores and slightly going up, but it's not very meaningful because it's just a matter of how you choose your data set, how that splits on those split and repeats functions. But now we have 10 different CVs in here, cross-validation scores. One quick question. Did I use final test set here? Yes or no?
No.
No, right. So if you remember this figure, this final test set is I never touched that. That is completely separate, different CSV file. I didn't read even. That test score is you train on your model in this 700 and test on this 300. They keep split and repeat in a randomized order of 5 different folds, and that is average score of that 5 folds, k-fold, k-equal 5 folds cross-validation score. So I never touched this final test score, but it's test score of the validation set. Okay. Oops, not this one. Any question on number 5? Good to go to 6?
I don't see anything in the chat.
Okay, let's go 6. So now we have to tune KNN model. Tuning KNN model means what was the parameter that I explained for in KNN? What you should decide in KNN?
Nearest neighbor, how many?
Yes, yes, that's correct. How many nearest neighbors you have to choose? And there is a function called grid search CV under scikit-learn model selection. That means basically you assign the grid, available grid, and then it would repeat exact same thing based on your grid. So here, first, the first line is importing this grid search CV, grid search cross-validation. The second line, parameters and neighbors from range 1 to 1001, incremental of 10. So 1, 11, 21, 31, all the 10 incremental, so possible and neighbors, and putting that parameters in grid search CV, and then do exact same thing, and then to fit in, okay? So let's write it together. And note that this step will take some time because you need to run with the various combinations that you can try. Okay, so let's try together. From scikit-learn model selection, import read search CV. Parameters equal curly bracket open and neighbors range 1 to 1001 increment of 10. Note that I was using model 2, which is KNN, basic KNN, but here new model is I put grid search, and that is grid search CV model 2 parameters CV cross-validation fivefold, same thing, scoring as precision macro, and return train score equal false. False. The next step is model to GS fit X and Y. So basically what it does is it puts first 1, 11, 21, 31, 41 until 990, 999 or 991. That all combinations and search which one is the best. And doing fivefold cross-validation for all the combination of n neighbors. And if it's a neural network-based model, then you can check it out, how many neurons, or like logistic regression, like sigmoid function or whatever functions you are interested in. You can check it out as a parameters and then run this model, put it in somewhere, and enjoy your coffee and come back here later and see the results. But KNN, only important parameter here is the neighbors, number of neighbors. So we did this. Any questions so far while it's running?
Could you explain like after like parameters equal n neighbors range 1 to 1001? Can you explain it again? Like what does that mean?
Sure. So once it's done, I can explain showing these things. So like you answered, the important parameters in the KNN model is what is the right number of n neighbors. And there's no free lunch theorem. You have to test it out everything. So if I type range 1, 1001, 10, that means from 1 to until 1001 and incremental of 10. Okay, that is, yeah. So testing out these all combinations in model 2, and then so very first one is 1, CV5 all running, 11 CV5 all running, 21 CV5 all running.
Okay, thank you.
Mm-hmm. So I guess mine is done. So the next step is model 2 research, which is I did, CV, results, parameters, friends. So this is what I just mentioned. We tested out n neighbor 1, n neighbor 11, n neighbor 21, until what? N neighbor 9091. That's all we tested out. And model 2, grid search, CV, results, mean, test, score. These are all score on corresponding to n neighbors. So this is corresponding to neighbor 1, neighbor 11, neighbor 21, neighbor 31, 41, and so on. Okay. Any question on this step? This number 6 step? No question? Okay, go to next step then.
Don't see any in chat, so I think we're good.
So the next step is we are plotting our results. I think you already learned the scatter plot from Dr. Aizuma's class, but here, let me change the order. What you need to do is a PLT, scatter, x equal range of 1 to 1001, which is your input, y equal model to grid search, CV, results, and then parenthesis open, mean, test, score. You got the scatter plot? Everyone get it? So what is the best score? Joel, can you say what was the best score?
The best what? I'm sorry.
Best score?
I think in the middle, near where the 0.45 is.
Yeah. And the X was around n neighbors around like 400, right?
Around 400, yes.
Yeah. So more precisely, you can.
Why is that the best score?
What is the best score?
Why is
You mean
that?
why is the best score? Because
Okay.
it's a higher number.
Oh, okay.
Yeah.
Okay.
So more precisely, you can return that numbers. Model 2, grid search. What was the best parameters first? That returns n neighbor 391. It returns the best score. And model 2, grid search, best score was 4426. So now finally you can check it out. Model 2, grid search the result. What was the best estimator out of you tested out? And that is k-neighbors classifier n equal 391. Okay. So basically, what I did in here is these cross-validation stuff for every k, not k-fold, but k neighbors, number of k neighbors. Okay? And that number of k neighbors based on the cross-validation on those number of k neighbor results is 391 neighbor was the best score out of 5-fold cross-validation. Okay? Any question on this? Okay. Anything on chat, Tanner?
Can I see the code, please? Like your version?
My version? Yeah.
When you're working on.
Yeah. Hold on.
There's nothing in chat.
Yep.
Can you scroll up a little bit more, please?
Sure.
Okay, thank you.
Mm-hmm. What is our last step?
You need to test with some of the data which you didn't use for training.
Perfect. All right. So for that part, we need to read that as a test. So that is the exact same PD read CSV, but data test.csv. That is never used for training purpose, but it's completely hidden and never seen data set. Okay. We need to test it out because your model will be going wild with the really raw data set. So okay. Python empty. So now you need to read the test equal PD read CSV data test.csv, reading your test data set. If you had the exact same thing, length was this. X test equals test.iloc. Can anyone explain what is the meaning of this code, what I just highlight?
Take the columns until 26 only.
Mm-hmm. And all the rows.
Yeah.
And that is your test set, which is a feature. And Y test is test location. So refer back to the number 1 section. Now we're utilizing this final test set because we feel confident on the training and validation set using cross-validation here. Now, because we feel confident, we're now using our model to test it with the test set. This one, test estimate accuracy, no model tuning anymore. Just see the results. Okay. Any questions so far?
Nothing new in chat.
Okay, so let's go to the last step. The last step is report your results. Okay, this code is a little long, but the very first one is scikit-learn metrics accuracy score. Scikit-learn matrix import confusion matrix. So basically, it calculates the accuracy score and confusion matrix for me. And then original model to predict X test. Now we're entering the test set because we want to see how test set look like. And tuned model is result of grid search model, right? Here. This is original KNN model, and this is after grid search model. Okay, then print original KNN, that accuracy score of Y test and original model 1, which is here. Model, not 1, just model. And then showing the confusion matrix by Y test and original model. And here, tuned KNN, which is a tuned model, and confusion matrix here. So let's write down this first, run this code first, and see the results. Interpret the results later on. So here, I need to from scikit-learn metrics import accuracy score from scikit-learn metrics import confusion metrics. Importing two kind of result evaluation tools, and then regional model equal model 2 predict X test, because this is a completely new one. Tuned model equal model 2 grid search result by predict X test. Print original KNN accuracy score Y test original model. Oops. Y test. Capital Y. So it is interesting because in previous cross-validation results.
I have a question.
Yeah, go ahead, please.
If you have an error like that, what do? Do you delete?
No, I just edit my code. So for example,
I'll rerun it again. Okay.
Yeah, here I just change this one. So I can see name Y test is not defined. Okay, so there might be some spell error. And go up. Oh, I used a capital Y, not small y. So I put capital Y here again. Okay.
Okay, and rerun. Okay.
And one interesting point here is when we do here, the original result was KNN of 39, right? But if we utilizing in a test set, it significantly increased. So we don't know. We sometimes having the purely test data set, you have a more increased accuracy or decreased accuracy. So you never know. That's why you need to keep cross-validate. And cross-validating it is guarantee more like conservative expectation about your algorithm. So CM equal confusion
I have a
matrix.
question. When you
Sure.
cross-validate and the KNN is increasing, is it a positive thing or a negative thing?
It's not a positive or negative thing. It's just a matter of your like data separation works.
Okay.
So I randomly divide into test and train set, and there's some possibility that my test set is favorable on my train set. So it's kind of like we cannot depending upon the luck on these things. So that's why we keep cross-validate. It gives you more conservative accuracy results based on the cross-validation.
So
But
the
yeah.
KNN 0.5 shows that the algorithm or the test perform better on your test data.
So you mean the comparing this 59% and this for 39%?
Yes.
Yeah, so based on the cross-validation, it only shows 39%.
Mm-hmm.
And we trained a model, and then if we test it on the test set, which is never
Mm-hmm.
seen before,
Mm-hmm.
it shows higher accuracy.
Mm-hmm.
But it
Okay.
is what it is. It's a matter of the data, like randomly, because it's randomly selected data sets.
Mm-hmm.
So it is what it is. But here's the thing. The reason why we're doing the cross-validation is really we want to see the better, more reliable accuracy results. If we have like kind of, if we train on the training set and testing on the training set, that it keeps shows the very high accuracy. But if we go to wild with that high accuracy, it never guarantee that high accuracy. Okay. So now going to the confusion matrix and Y test original model. And oh, I have to print CM. What does this mean? What does this 881 mean?
No idea.
No idea? Let's go back here. Prediction,
Okay.
positive, negative. Target, positive, negative.
Okay.
So what was our target here? What was our target? What do you want to classify?
The
What
location
was
based
The,
on
the,
the electrical
the location, yeah.
location, right? So this 881 means computer, this our KNN model predicts or classify this one as urban building. And actually, it was urban building. So 881 is correctly classified as an urban building. 24 is correctly classified as urban cluster building. 106 is correctly classified as plural building. Make sense to everyone?
Yes.
Okay. And these 204 is basically computer classified it as urban building, one, but in reality, actual data set was number 3, which is a rural area. So there's a mismatch between computer and the actual results. Okay. So if I add them up, all these 9 numbers, what should it be?
Total number of buildings.
Yep, which is a 1686. And out of 1686, they classified successfully on 881, 24, 106. In that way, you can calculate the accuracy. Okay? Makes sense for everyone?
Yes.
Okay. You good, Joseph?
Yes.
Okay. Okay. So now let's report the final results. So print now tuned KNN. What was the K number? That was 391, right? That was a tuned results. We used grid search to identify what was the best score out of various K combinations, right? And accuracy score of Y test tuned model. It was 69. And CM tuned equal confusion matrix Y test tuned model print CM tuned. Okay. Why we have a improvement from original KNN to tuned KNN? In other words, what was the main difference between original KNN versus tuned KNN?
I think tuned KNN is that the computer have seen some of the numbers before.
Yeah, so we tested out the combination from 1 to 1001 incremental of 10 for all the K neighbors conditions. But what was the original KNN? What was the K number for original KNN?
I think it's 0.3.
It was
0.3.
Yeah, that's the accuracy. But what was a K number? K neighbor.
Yes, 3.
It was 1. You remember
1.
the very
Okay.
first step? I put
Okay.
K n neighbor equal 1.
1. Okay.
Yeah. So compared to the original model, which I didn't do anything, we did the grid search and we identified 391 was optimal. We
Okay.
saw from 1 to 391, it increased around like 10% accuracy. Okay.
Yes.
And here, but note that there's all zeros on the second thing. So because it's a higher number K. So this KNN algorithm, I try my best to classify these urban cluster building rather than I'm the urban building rather than urban cluster building. So it's a kind of bumping the accuracy by urban building, not the urban cluster building. But anyway, it increased the accuracy out of it. But majority of them are urban and the rural area classification from the KNN algorithm side of point of view. Okay, but anyway, it increased the accuracy by 10%. So this gives you important lesson. The only accuracy is, looking at only accuracy is kind of dangerous, kind of jeopardy. You have to see confusion matrix to see how it performed in actually, or how they classified and what was the actual labels, so that you know the real performance of this classification algorithm. Because, oh, hooray, it's a 10% accuracy increase by tuned KNN model. But in reality, it didn't do any prediction or any classification for the urban cluster. Okay? Any question on report your results?
No.
Okay. Any question on this part, the coding?
Yeah, I think like if you can give a glimpse about this cross validation, maybe a small summary, because I couldn't be there like when you started. Maybe like
Okay.
Yeah, just a glimpse, right? Okay. Yeah.
So thanks for asking that, because this is super important lesson. I think this is the most important lesson I would like to give you. So there is a bias and variance trade-off in ML. So bias is error due to assumptions. High bias means underfitting. Model does not capture sufficient characteristic of data. So that is simple AX plus B line, Y equal AX plus B line. It never captured the data. The variance is error due to sensitivity of model. The high variance means overfitting. The model captures noise in the data, like this. So how to avoid this kind of situation? Or how can we then evaluate and improve the performance of a given model? And that is why we need a cross-validate. For example, let's say we have 1100 data points. You must put 100 data points as a final test set, which is a hidden data set. You're not going to use for training purpose. But out of that 1,000 data set, you can divide into 700 and 300. And 700 is going to the training set, and 300 going to the validation set. Okay? So here's an important thing. If you just train on your training set, then your error will go down, and your model is really complicated, like this one. And you train on your train set and you test on training, so training error will go down. But if you go in reality, that will give you bad results on the final test set. So just not going to the complexity is not good an idea. You have to stop somewhere, like here. For that, you can do split and repeat. That's the cross-validation. Maybe this is a better figure. So assuming that this is 1,000 data set and this 300 and all white is 700. You select randomly 300 and then training the model in this 700 and test on 300. Round 2, select the different 300 and train the model from the other 700 and test on these different 300. Round 3, keep split and repeat, split and repeat, split and repeat. Based on your data selection, you might have a different accuracy results, 80, 85, 81, 90, 92, and take an average, because that's more real results, accuracy results that you can achieve in real life. So we have to cross-validate from all different combinations that you can choose. And depending upon you choose this fold number, this is a 5 CV situation or 10 CV situations. And then you can report that number. And this is a good and choice of a single training test set, provides sensitivity of model to data, use the data more efficiently, but it's computationally demand. But cross-validation is always necessary, because you have to, your model finally going to the not training world, not the incubated word. It goes to wild, never seen before. So you have to be harsh on your validation of your training data set. Okay, so do you have any question on cross-validation?
Now I think it's clear to me. Yeah.
Okay.
Yeah.
Glad that it helped. So that's that. This is all step, and I think I also upload the complete Jupyter Notebook to my GeoHub. So feel free to download it, and it's quite easy and easy to go kind of Jupyter Notebook. If you have your own data set, you can change your own CSV data set here if you're not interested in building energy data. And depending upon what features, you can change the features. And note that we use the raw data, raw features, but you can convert these raw features to whatever you like. And then here, I use a tree and neighbor model, but you can select the neural network model or SVM, all the model that you can choose. And based upon the model you choose, your classifier regressor will different. But same thing, the fit XY is the exact same, cross-validation is the exact same, and tuning is the exact same, except for what parameters you want to choose. I use neighbors because that's the typical parameter, like searching in the KNN algorithm, but you can do whatever you can, like search for your grid search, utilizing grid search. And then you use the test data set, never seen before, and then accuracy score and confusion matrix to analyze your results, to report, and to fully understand the performance of your classification algorithms.
Dr. Park, I have a question.
Sure.
So in the presentation from earlier today, when you showed us the example of the orange, there was 2 columns, one for positive and one for negative, and then the 2 rows for true and false. So my question is, in the confusion matrix at the end of this code, why does the array a 3x3?
Because what was our classification target? Do you remember?
They were those 3 categories.
Yes, urban cluster, rural. So the example that I showed you in the lecture portion, I mean the very early morning portion, like you said, it's a 1 or 0, orange or not orange. But in our classification target in this new problem is either urban cluster, or rural. So now it creates a 3x3. So if your classification target is based on their like working hour, what is their grading? A, B, C, D, E, F. A, B, C, D, E, F. Then it will create 6x6 confusion matrix.
Okay.
Does it make sense to you?
Yes.
Okay.
Thank you.
Thank you. Thanks for asking that.
I have a question.
Yes, please.
Creating more classification target, does it increase accuracy of our algorithm?
In this problem, we only have 3 different classification target. That's available classification target. So you cannot increase the classification target just whatever you want to, because that's the available data. Whatever I receive this data from the Rex data format, it's only 3 locations.
Okay.
Yeah.
Okay.
Any other questions?
Why I'm asking is in case you are dealing with raw information, like you just pick up data from energy energy data and there is no classification and you have to do the classification yourself.
I don't get your question. So can you elaborate
What I'm
more on
asking
that?
is there a possibility that you get you doing a research and you jump into this data from maybe just energy and they are picking data from different places and you have to classify it yourself?
So that means if I have more classification targets, so like location by rural and extremely rural area, for example.
Yeah, maybe the data is you.
But in that case, because I never learned extreme rural cases in my training data set, so I
Okay.
cannot, I mean, this model cannot classify that type of classification target
Okay.
because it should match with the training and the test set in terms
Okay.
of the types of targets. Yeah.
So that means this program right now is strictly on this classification target.
Exactly. But
Okay.
that's important question.
Mm.
You can create whatever you want to. So if your like CSV data has classification target of 5
Mhm.
or 6, A, B, C, D, E, F, like a student grading, and your very end, like grading A, B, C, D, E, F, then you can, that is like 6 classification. You don't need to
Mm.
change anything, but the code will automatically will give you the 6 classification target classification problems.
Okay.
Yeah.
All right. So
Mhm.
you can still solve the same problem with this framework here.
Yeah, this is more like a framework, but
Okay.
you have to change a little bit. For
A little
example,
bit, yeah.
if the feature number is not 26, but 25 or
Mhm.
19 or 18, then you have to change this iLock information here.
Okay.
Yeah.
Okay.
And if you want to, for example, not want to decision tree, but other SVM algorithm, then you have to change your algorithm here.
Okay.
Mhm. But other than
So
that, it's almost like same. Yeah.
yeah. So in understanding this, one can use this as a portfolio where you start modifying the learning procedure for writing in Python.
Yeah. Oh, sure. And this procedure follows the cross-validation, which is a very typical and very basic
Okay.
procedure you have to learn. So that's why I keep emphasizing that you need to know what is the meaning of cross-validation and why we put the cross-validation as a very important step in number 5.
Yeah. Okay. I think I have
Yep.
to go study it some more, then understand all the intricacies involved.
Yeah.
I think the most
But
part of it is understanding it and being able to interpret
right,
the
exactly.
result you're getting.
Exactly.
This is a great illustration. Thank you so much.
Thank you. Thanks for listening to this. Any other question?
I have another question.
Please.
At the very end, once we're trying to interpret our information, we once we switch from the original model to the tuned model, our accuracy improved. But I would say not by much. So my question is, how could we improve the accuracy of this even more?
Even more. That's a good question. So let's do it this way. Oh, feel free to take a break because our session ends at 15. So, but I'm going to explain. For example, this one. K neighborhood classifier. Tab. And there are various parameters you can change. One parameter I changed was n neighbors, right? And that was the grid search wise I used from 1 to 1001 by incremental of 10. But what if I change incremental of 1? So that means n neighbor is checking 1, 2, 3, 4, 5, 6, 7, 8 until 99, until 1000. So it will take longer time, but it will give more results of the k numbers. And you may find the better results on that, right? Or other parameters, you can check it out. So simple answer here is you can do detailed grid search on n neighbors, or you can find other parameters you can play with so that you can improve the accuracy.
That makes sense. Can you scroll down to the bottom again?
Yeah.
What was the keyboard shortcut you used to see that drop-down menu?
Yeah, it's a tab. Tab
A
key.
tab.
Yeah.
Okay.
So in Jupyter Notebook and Python, always tab gives you what is available functions or types you can use. Tab key is always, that's one of my favorite keys.
Good to know. Thank you.
Mm-hmm. Glad to let you know. All right, so we're going, oh, go ahead, please.
How did you go into that? I mean, getting those, there's something you just showed earlier on.
The tab key?
Yes, that key.
Yeah, so like, for example, like data equal PD, which is a pandas data frame, dot tab key gives you all the available under PD. Yeah.
Okay.
Yeah. So tab key gives you all the available Python script that you can call under that libraries or that imports.
And then you choose one.
Yeah.
One other question, please.
Yes.
Now, because these are different section of execution on Python, how do you establish a library whereby you can store things that you've done? That way, when you go back, you'll be able to understand.
So you mean, how do I call the libraries that I never used?
No, that's not what I'm saying. You know, like you executing this on Python. It's a different, it's a complete algorithm, right? But yeah. So if you want to do something different, like create, like I'll say, like, okay, you've done various stuff in Python, and how do you keep track of what you are doing? Do you have a particular storage where you put these items and you can just call them up and look at them and see what it looks like, and you can easily understand it?
Oh, okay. So in that case, you have to go scikit-learn.
Okay,
This is a library for this sklearn. Okay. And then classification, for example, classification comparison. What we did here was decision tree classifier and k-neighbors classifier, right? But you can, for example, you want to test it out, I don't know, like neural network model, artificial neural network, then copy and paste this in your code and then check it out how MLP works. So I don't have any like repository to look up, but whenever I need to do something else that I never used, or I also use these algorithms, but I never stored in somewhere, but just look up their like main library website.
Yeah.
Does that answer your question?
Okay.
Yeah, so go to this scikit-learn webpage and
Mhm.
hover around, play around, and copy paste the code and check it out with your own data. That's
Okay.
the best way to learn the machine learning for
Okay.
your domain data.
Is it
Okay.
under my GeoHub? Or is
You
it
mean this
different?
website? This
Yes.
website?
Yes.
No, this website you can just Google scikit-learn.
Okay. Psychic
Yeah.
learning.
Yeah. SCI kit learn.
Okay. Yeah.
Yeah. Cool,
That's
cool.
it.
Right.